Hello friends, welcome to Study Khazana. I'm GS Jha, and today we'll be conducting sessions for projectile motion, motion in 2 dimension, and the level of course will be for IIT-JEE. So it will cater to both JEE mains and advanced. So essentially starting with the motion in 2 dimension, if we talk about the motion in 2 dimension, you'd realize that the motion in 2 dimension is essentially there are 2 broader aspects to that we study. One is about the projectile motion, and other is about the circular motion. Now in this lecture we will be focusing most on the projectile motion. So now coming back to the point of the projectile motion, the projectile is something that is thrown under the influence of the gravity, and obviously it has been a very important topic for the both JEE mains and advanced over the years. And so because there's a different point of view that there are different results which are essentially asked, but we have to see that those results, before that result we need to understand the assumptions that we take. So one of the assumption is that the air drag we normally neglect, and the G also remains constant. So how do we analyze the motion? We will be discussing with the help of the mathematical equations, and there is a lot of fundamental mathematics involved, including the application of the vector and the calculus. That also will be taking into consideration. And in the later part of the lecture we will be discussing the numericals associated with this, and at the end of the lecture we'll be discussing a kind of summary of the whole lecture. So I would start with the mathematical different derivations of the expression of projectile motion, and you can follow each of them with the equations. So if we see a kind of projectile motion, it is like it is thrown with angle theta. If you throw with an angle theta, then the motion has to be analyzed in 2 particular points, 2 particular axes: the motion along x-axis and motion along y-axis. Motion along x-axis and motion along y-axis. Okay, so if you see the motion along x-axis, the fundamental point is that in the x-axis actually there is no accelerations because there is no force. So velocity will remain constant, while in the y-axis we have the acceleration due to gravity. The G is actually working vertically downwards. So how we'll analyze the motion is that we will try to split the motion into 2 parts: the motion along the x-axis and the motion along the y-axis. Now when we move forward, if you can say that we'll write the equation for the motion along the x-axis. Now x equal to u cos theta into t. As I mentioned that since the velocity is constant, and that is u cos theta, so we can write the expression as x equal to u cos theta into t, and y equal to u sin theta into t minus half gt square. If we do so, you'll realize that in the y direction we have mentioned the acceleration at the minus g, and which is quite evident because the acceleration due to gravity is present in the downward direction. So now if we analyze this, so if you look at the motion again, you realize that there is a point on which the motion starts A, and on the point at which the motion ends as B. So on both the A and B, the y coordinate is 0. So putting y equal to 0, we get u sin theta into t minus half gt square equal to 0. Now if you take t common, you realize that u sin theta, that we will get 2 values of t at which the y coordinate is 0, and the first one is of course t equal to 0, where the motion begins. Now interesting value comes from the second part, because there we get the t equal to 2u sin theta by g. Now if you see this, you realize this is what we call the time of flight. So essentially the time of flight is the total time during which the projectile has been actually in the motion. So from A to B, this you can say the traveling time of the projectile. Now we would go further and realize that now we got the t equal to 2u sin theta by g. This is the time of flight. There's another interesting point now comes in that we have the horizontal range. Now the range is defined as the horizontal distance covered by the projectile during this time. So if you see the diagram, you would realize the distance AB is actually nothing but the horizontal range, and that you can find out by using the equation along the x-axis. So we get it u cos theta into t, that is time of flight. So virtually it is u cos theta into 2u sin theta by g. It becomes u squared sine 2 theta by g. Now, so this is the value of the range that we get, and of course we'll come to the mathematical points, but very basic point is that maximum value of sine 2 theta, maximum value of sine 2 theta is actually 1. So R max, the maximum range could be u squared by g, but that's one point. The another point is that at what value of theta this will happen, and so what we have assumed is the 2 theta is actually pi by 2, 90 degree. So theta equal to 45 degree or pi by 4, which is the angle at which the range is maximum. Another important result, and which is very, very crucial for us, and in the later part of the result that we would using it further. But now moving forward, we would see that what is the kind of maximum range that we have to deploy, and so we would see the maximum range that will come up, the maximum height that will come up. So now using the equation of motion along the y-axis, we once again write y equal to u sine theta into t minus half gt square. Now interesting point is that here, if we get the value of t, we can get the y coordinate for all the values. So of course, so now our next point of focus is what is the point, how much time the projectile takes to reach the maximum height, and how do we get it? So let's say from A to B, if the projectile reaches at a point P, which is the maximum height, and I call it capital H. So how do we find out? So there's one interesting point which needs to be understood, is that at maximum height, the vertical velocity will be 0. I would again re-emphasize that horizontal velocity never changes during the projectile motion. It remains as u cos theta. So you can write Vx as u cos theta. But as far as the vertical motion is concerned, you can write horizontal velocity remains u cos theta. Vertical velocity actually Vy equal to u sin theta minus gt. So another MCQ question which can be framed up is that how does the velocity in the y direction changes during the projectile motion? It continuously decreases, because you'd realize that at this stage the Vy is actually, the maximum value of Vy was only during the initial time at t equal to 0 of the when the body was projected. Now as the time progresses, the value of time goes up, the Vy actually decreases. And at what value Vy is 0? So when Vy is 0, body reaches the maximum height. Now maximum height, so we can get the value of time, and that time we get is u sin theta by g. Now essentially there is another important aspect to it, because if you see the value of time of flight that we have obtained earlier, it was double of this value. So now the physics is quite clear that the body takes half the time in reaching the maximum height. And so symmetry also very much makes it quite clear that from A to B, if we take 2 seconds, a body takes 2 seconds of full time from traveling to A to B, then in 1 second it will reach the maximum height. And so this is the time of ascent at which the body is actually moving up, or this is the time required for body to move to the maximum height. So now we have got the value of the time. We would use this time to reach at the value of the y, that is the maximum height. So that will be our next point of focus. So if you see this, then probably you can see that next point of focus will be, so just using this value y equal to u sin theta into t minus half gt square, and now we have value of t equal to u sin theta by g, if we put the value of u sine theta by g, we get y equal to u sine theta into u sine theta by g minus half g u sine theta by g whole square. Now, if you see u square sine square theta by g minus u square sine square theta by 2g, and solving finally we get u square sine square theta by 2g. This is the value of h, maximum height. So, we have earlier derived the result for the horizontal range, and now we reach to the maximum height h. So, interesting point is that the point we derived just now, that at theta equal to 45 degree, the range is maximum, but that is not the angle at which the height is maximum. If you see this expression, this has sine square theta. The maximum value of sine square theta can be 1, and so using that we find out that theta equal to 90 degree, the h is actually maximum, and so we reflect upon that. So if h max actually is u square sine square theta by 2g with theta equal to 90 degree, so u square by 2g. Okay, so if you see this, so you realize that there are two cases. So the case in which the horizontal range is maximum, it is not the case in which the projectile attains the maximum height for given angles. And for the same case, if the theta is 90 degree, then of course horizontal range becomes 0, because the projectile does not cover any horizontal distance, because horizontal velocity becomes 0. So these are the two cases which we have come. Now these are the, so I would again remind the results. So we have derived the results like t, time of flight, 2u sine theta by g, which is the first result we got. We got another result, the range, u square sine 2 theta by g, and we also got the result h is equal to u square sine square theta by 2g. But remember, these are all the points, boundary points that we have calculated. So for example, we have calculated the particular points. Now let's say there is also an angle that we need to look into this particular projectile motion study, is that the projectile for any given value of y, if we are how do we correlate between the y and x coordinate, and that will throw some of the mathematical elements into this particular discussion. So if you see that particular point moving forward, we would see that we had two equations, x equal to u cos theta into t and y equal to u sine theta into t minus half gt square. Now what essentially the effort now is that we want to eliminate the time t, and we want to establish a relation between x and y, and that is what is called the equation of trajectory. So we will establish this, and for this we will try to get the value of t as x equal x by upon u cos theta, which we can get from the horizontal equation. Now putting this value into the vertical equation, we get so we get y equal to x tan theta minus gx square by 2u square cos square theta. So there is this is called the equation of trajectory, and very important, because if we want to analyze any case in which it is neither the range or any intermediate part of the motion, then we can use this y and x coordinate. Now if you look at the equation, you would find out this is a kind of parabola, and I would like to generalize it by saying y equal to ax minus bx square. So this is the equation of the parabola, y equal to ax minus bx square. If you would be familiar with the basic background of the parabola, you would realize that this is the parabola, and which is like which has two minimum points, the 2 points where y is 0, and if we can also get the value of the maximum value of the y from this using the calculus, that will come to the part later, but this is the equation of the trajectory. Now if you look at the first equation that we have derived for the equation of trajectory, the theta is, x is quadratic here. So it shows that there will be two values of x, and that is very, very clear, because if you, let's say the body started the motion from A to B, and let's say we take up P1 and P2 as a 2 points. So let's say during the, and I call it P as the maximum height. So let's say during the ascent of the body is moving up from A to P. During the time, the P1 is a height that is attained by the body, and during the, when body falls from P to B, that is from the highest point to its ultimate destination, that is B, also there is a height called P2 of the same height, a small h, if both I denote with a small height h. So if you look at these two particular points, you realize that, you know, for these two values, y is same but x are different, and it is very clear from this equation that this is a quadratic equation which has a value of y and x is quadratic, so x will yield the two values. Of course, we can get the value of these two coordinates, x1 plus x2, with the help of the equations, so that is possible. Another point is that we can also, you know, make it further with the writing that cos square theta as 1 by cos square theta as sec square theta, and we can derive this as 1 plus tan square theta. So it is quadratic in the theta also, tan theta also. There will be two values of tan theta. We would be using, now the next point is, where do we use equation of trajectory? So equation of trajectory we use whenever we have the x and y value available, and let's say the question comes that a particular ball is thrown with a particular angle, and after at a distance of 3 meter horizontal distance, it wants to clear a wall of 5 meter. Then we have to put the value of y as 5 and x as 3, and of course we have to put the theta, and then we can get the value of u, or if the u is available, then we can get the y or x values. So interchangeably we can use this. So now we come to the next point. We will focus on the velocity part, that how the velocity changes during the projectile motion. So let's see, when we have drawn the equation, and we had two velocities, Vy equal to u sine theta minus gt, and Vx equal to u cos theta. Now, as I mentioned during the initial start of the discussion class lecture, that actually the horizontal velocity never changes. The fact is very clear, because in the horizontal direction we don't have any acceleration or any force, but the vertical velocity it changes, and at the maximum height the vertical velocity is 0. So at maximum height you have only one velocity, u cos theta. So there is no other velocity. So during the motion, this is the one point where the vertical velocity is absolutely 0, and so horizontal velocity is the total velocity. But during the motion at the other points, if we want to keep to get the value of the total velocity, so let's say we do a very clear point that at this point I want to get the velocity value of v. I have a vx and vy, so v will be equal to root under vx square plus vy square. Now if you see this Vx, you would realize that Vx is u cos theta whole square, and Vy is u sin theta minus gt whole square. So if you solve it using the mathematical identity that cos square theta plus sin square theta is 1, you will realize this is u square and plus g square t square minus 2u sin theta gt. So that will be the velocity of the v. So the benefit of this equation is that you can get the velocity at any point of time. So that, let's say if a body is projected from A to B, and let's say we take the body takes 4 seconds to reach to the point B. So we can say the time of flight is 4 seconds. One thing is quite clear, that in 2 seconds the body will reach the maximum height. So let's say that is fine. So if one question which can be very, very easy to handle is that you would be given the time of flight as 4 seconds, and they can ask you that what is the velocity at t equal to 2 seconds. So that will be quite easy, because it is the point at which the body is at the maximum height, so horizontal velocity will only be remaining there, vertical velocity is 0. So this will be equal to u cos theta. Theta is given, so let's say theta is 60 degree, so this becomes u by 2. But at any point, let's say as I mentioned in the problem, that 4 seconds is the total time of flight, and 2 seconds is the time at which the body reaches the maximum height. We want to get the velocity at the end of the 1 second. How can we get it? So we have to put the value as value of the u, we have to get the value of the theta and the t, and we can get the value of the v. That is one aspect of the velocity. There is another aspect of the velocity, that how much angle the body is now making with the horizontal. So initially the body was making an angle theta with it was projected. So we can get the value of that also, and we would describe that. So let's say tan alpha is defined as Vy by Vx. So let's say if you project it with the body with this and realize this is alpha, then this is Vy and Vx. So then tan alpha is Vy upon Vx. So tan alpha, you can say u sine theta minus gt upon u cos theta. So this is the value of the velocity. This is the value of the angle that the body makes. And of course, when u sine theta minus gt is 0, you will have tan alpha equal to 0. Now another important aspect at this stage is that we can solve the numerical there, because there are some of the problems which can be we'll be solving in the second half of this discussion, is that that at after what time the body actually becomes the perpendicular to its initial direction. So we'll use this particular expression. We can also solve that through the vector. So that we have so important results that we have got is, we have got the time of flight, and I would highlight that whatever results we have got, time of flight 2u sine theta by g. We have also got range u squared sine 2 theta by g. We have got value of h, u squared sine squared theta by 2g, and at the last we got the equation of trajectory y equal to x tan theta minus gx square upon 2u square cos square theta. Okay, so these are the 4 results which you need to derive, and also you need to remember it, because these will be, even for the very basic questions you will need these. Now we'll come to some of these are very, very basic results. Now we will come to some of the standard results which we can derive from these expressions. Okay, so let's say we just now said that a body is projected, and you have these 4 fundamental results coming up. Now let's say a body is projected with an angle theta. So for complementary angles, we would see how the impact comes up. So we know that r is equal to u squared sine 2 theta by g. Now if the body is projected with a 90 minus theta angle, so we'll see r dash equal to u squared sine 2 90 minus theta upon g. So it becomes u squared sine 180 minus 2 theta. So those who are familiar with mathematics can easily understand that sine 180 minus theta is actually sine theta. For those who are not, can actually use slightly different method for understanding this, and then even if you use the sine 90 minus theta cos theta, that result is absolutely fine, because that will come up. So we see that r and r dash are same. So the result which is coming up is saying that the range is same irrespective of the fact that whether you project it with theta or you project it with 90 minus theta. So what is the importance of this result? So let's say if a ball is projected with an angle 30 degree and another ball is projected with an angle 60 degree, you will realize that essentially the range will remain same. And so this is a very important result. So ratio of the range will be equal to 1. You can definitely say that. Okay, we'll also see how the maximum height and how the range and height has a correlation. So let's see. So range we derive as u squared sine 2 theta by g, and h is equal to u squared sine square theta upon 2g. Now we want to find out that how much the r upon h is. So let's say r upon h we do u square sine 2 theta by g upon u square sine square theta upon 2g. U square gets cancelled and g also gets cancelled. So 2 goes up, and then 2 sine theta cos theta, and then sine theta into sine theta. This gets cancelled, so 4 cot theta. So the result is r is equal to 4h cot theta. Okay, so this is very, very clear. So one of the results which can be derived, that theta is 45 degree, then range is equal to 4 times the maximum height. So r equal to 4h in that case. Okay. So now we'll come to some of the mathematical part in the vector and the calculus, how we can analyze the projectile motion. So we'll see that, and if you see that, so let's say what we have done is initially that we have written the velocity as v equal to u cos theta, and if you write in the vector form, plus u sine theta minus gt j. And the time of flight which we are getting is 2u sine theta by g. So if you see that time of flight, you can write, so you have you can write time of flight as 2 uy upon g, and vector form you can write the u cos theta I plus u sine theta minus gt into j, gt j in the y direction. So this is the overall application. If you look at the r also, the range, you can actually write the range as a range formula which we have written was u square sine 2 theta by g. Now if you see the formula of the range, then you realize that there is a sine 2 theta can be actually bifurcated into sine theta and cos theta. So we write here 2 u square sine theta into cos theta upon g. So we write it u sine theta into u cos theta by g. So if you look at this result, you realize that this becomes r equal to 2 into ux uy upon g. Now where the ux is important? So let's say there is a question in which you are given that a particle is projected with a velocity 5i plus 6j initial velocity. Here you are not given the angle, and you need to find the range. You actually don't need to calculate the theta, because that method can also be used, but that will be slightly lengthier. So to save the time, what we'll do, we'll use that ux, and ux in this case is like 5, and uy is, so for example, let's say if I want to solve this question, I can directly say that okay, what will be the value of the range? So I will put 2 ux as 5 and uy as 6 and g as 10. So if I do so, I can say if the 6 unit is the range. So this is the benefit of the vector. Now we'll focus on some of the results coming up from the calculus. So we analyze the projectile motion from the calculus point of view, that how it reflects. So let's see. So let's say when we talk of this projectile motion, and we said it's a parabola, and the equation was resembling as y equal to ax minus bx square, and in the form of y a, if you see, it was x tan theta minus gx square upon 2u square cos square theta. Now interesting point is that if you look at the highest point that we have called up consistently as P, this is the point at which the tangent is actually parallel to AB, that is the axis. So the significance is that, as we know from the mathematics calculus, the dy by dx is actually the slope of the tangent. So if we further delve into the details, we realize that dy by dx at this point should be 0. So let's say dy by dx has to be 0. So if you do so dy by dx is 0, and so let's say ax minus bx square, if you say dy by dx 0, it becomes, you realize with you differentiate the y the expression, complete expression with respect to x. So it becomes dy by dx equal to tan theta minus g into 2x upon 2u square cos square theta. Now, if you look dy by dx equal to 0, you can get the value of a x, and let's say what the value of x we are getting. So what you essentially get is x is equal to r by 2. So this is the point at which the dy by dx is actually 0. So you get the value of x, and then if you put into this, you can get the value of y. Now another important aspect that we need to understand is that, let's say you are given a equation of trajectory. So let's say there is a question called y equal to root 3x minus 5x square. So this is the equation of a projectile. Now you have to find out that what is the range of this particular a projectile. So let's say that there could be two questions on this. One question could be that find the angle of projection. So that is very clear, that is very evident, that we compare it with the equation of trajectory y equal to x tan theta minus gx square by 2a square cos square theta. If we do so, we find out that tan theta is root 3 and theta is 60 degree, which is very clear. But now let's say you have to find out the range. So for range, what you have to do, you have to put get the u, you have to get the theta, and then you have to get the sine 2 theta. What as a substitute from the mathematics you can do is that if you do y equal to 0, as we have discussed initially, that when y equal to 0, body is at A and B. A and B, as I am saying, is the starting point and B is the ending point. So when body is at A, obviously that's a t equal to 0. But when the body is at B, so when you put y equal to 0, you will get actually take x common, you will get the two values of the x. One value of x, which is you are getting a 0, is of course the time t equal to 0, and other value of x which you get is root 3 by 5, and this is the value of the range which you can actually calculate. So obviously these are the aspects which we need to focus in particular these things. Now let's say some of the more results we'll be discussing for projectile, because so before moving ahead, what we have discussed, nutshell we can say, we discussed about the projectile motion basic assumptions, then we derived the basic expression for the time of flight, for the range, for the maximum height, and for the equation of trajectory. Now after that, coming to some more specific results on the complementary angle projection, theta and 90 minus theta, we find out, and then we also moved into the domain of the vector, and we realized that that how the vector comes into the picture, that how the vector can help you in solving the projectile motion question, and finally from the angle of the calculus, we saw that the dy by dx is one point which we analyze, then we can get it at any point. Now we'll see some of the more results. So let's say now as we mentioned, that interesting point is, let's say so a body reaches at a point, let's say called r. So at this point, and t1 is the time which body takes to reach at this point, and t2 is the time body takes to reach at from R to B, that is the final point. So obviously we can say t1 plus t2 is 2u sine theta by g, and let's say r is at height h. So h, if you derive u sine theta into t1 minus half g t1 square. Now what we are trying to correlate how the h is related to the t1 and t2, and we can actually do it very comfortably, and this is one result which we can use, how the t1 and t2 can interchangeably be used. So now these are the standard results which you can commit to your memory and also use it in different problems, so that will increase the speed at which you can solve the problem. So let's say now if you look at from the first equation, we can get the value of u sine theta as g into t1 plus t2 upon 2. Now putting this value of u sine theta into the next equation, H is equal to G into T1 plus T2 by 2 into T1 minus half G T1 square. Now moving to the next page where we actually, so what we essentially got is, so if you look at the result that we had, we said that u sine theta into t minus half g t1 square is 0, and u sine theta was actually, t1 plus t2 was 2u sine theta by g. So u sine theta was g t1 plus t2 by 2. Okay. So now put y is in place of y we put the value of h, because that is the height given for that particular point r, and in place of u sine theta you put this expression g t1 plus t2 by 2 into t1 minus half g t1 square. Now if you see here the expression half g t1 square gets cancelled. So what we get is half g t1 t2 is equal to h. So if we going back to the point where we started the problem, we can say that this is the particular point h at which, so if we are given the, let's say a height is given, and how we can use this in the problems is that I will explain further. So let's say you are given that a projectile is projected in such a way that at a height of, let's say, 5 meter, it takes 5 seconds before reaching that height. Okay, then how much time it will take after that height, to reach to its final point B. So or you can say what is the total time of flight. So essentially, if you put this equation h equal to half g t1 t2, you are putting the value of h, you will get and t1 you will get t2, and t1 plus t2 will give you the range. And also the another point can be, which can be asked, like t1 t2, if t1 plus t2 is known, then what can be asked is that what is the vertical component of velocity at t equal to 0, that is u sine theta, and we have seen that t1 plus t2 is 2u sine theta by g. Okay, so I think we have discussed quite a lot of results. Now last point that we focus is on the energies and side, that how the energy moves during when a body moves during a projectile motion, how at different points, let's say at the starting point and the maximum height, the energy changes, and so that point we'll see. So let's say at the initial point, if you see, we have been calling it A, and the final point B, and the maximum height as P. So at A, if you look at energy, the body has both horizontal velocity and vertical velocity. The total energy, if you look at, was half m, and both kinetic energy u sine theta whole square plus u cos theta whole square. So essentially it is half m u square. Okay. So now look at, if you look at the point P at this stage, the body does not have the vertical velocity, but body has a potential energy. So let's say you call it potential energy. So energy at P, if you calculate, the body has total energy as mgh plus half mu square cos square theta. Now if you put the value of h u square sine square theta by 2g plus half mu square cos square theta, so you would see the g gets cancelled, and this also becomes half mu square sine square theta, and half mu, so this becomes half mu square. So this is perfectly fine with the energy conservation. So from A to P, if we see that energy at any point remains same, what is actually happening is that since vertical velocity was decreasing at that magnitude as well, so what was happening is that at this stage, so vertical velocity decreases, and that the gain is converted into the potential energy. So this is particularly important, because if you see that if you see that from A to P, And from P to B, if you see again the potential energy decreasing, but this time the kinetic energy will actually increase. Though the vertical velocity remains negative, but the fact is because it's a square of the velocity in the kinetic energy, so the impact is overall and neutralized. So one more thing that is important to see, that how we have seen the equation of trajectory, that if you see the one projectile from other, you will see that half gt square part in the equation of trajectory will get cancelled, and so actually it will look like a straight line. So if you are, let's say, if a body is projected from A to B, and let's say reference frame is like this body, and another body is also projected at the same time. So from the one projectile to another, the motion of the second projectile with respect to the first projectile will be considered a straight line. The last result that we'll discuss today, which is a very derived result, I would say, is like, let's say if you have body and there are 2 points, let's say A and the another point is like let's say B. Now A has a conjugate point A dash and B has a point like B dash. So when body is moving up, it first goes to B and then goes to A, and then during the time of descent, descent is like body is falling from the highest point to bottommost point. So when it is coming, the counterpart point for A is A dash and B for B is B dash. If we do so, you realize that from A to A dash, let's say, and if the height difference is h. Now if it is given T1 is the time difference between A to A dash it takes, T1 A to A dash it takes, and for B, T2 is the time with the B to B dash, then T2 square minus T1 square will be 8h by G, and with the easy mathematics you can derive it, and you can also remember it because this result is critical. There are some of the other results also which can help it, but as I said, the projectile motion involves a lot of mathematics, so analyze it from the angle of calculus, from the angle of vector, and then also use the physics. So 3 results could be could be supplementary to each other and will help you to understand the concept very well. Now in the last part of the lecture, what we'll do, we'll focus on the kind of numericals that can come up for us, and obviously some of the numericals we have discussed during the theory part only, but separately we'll discuss the type of numericals which can come up. So let's say the type 1 numerical, which I say could be the very basic numericals where you could be asked the value of the height, maximum height, range, time of flight, and let's say equation of trajectory also you might have to use, so value of y. So this can come up, and obviously here the fact that you have to see that angle will be given. So these are like a straightway problem. What we need to do is that we should have a very clear grip on the formula. We'll deploy the formula, and in fact even for the equation of trajectory, if you remember the equation of trajectory, you can easily solve these questions because there is nothing much in terms of the calculation that you need to do. Just put up the values. Of course, for this is quite clear that you need to have a trigonometric table very clear, sin theta, cos theta, tan theta values from 0 to 90 or 120 also, if you remember. That's absolute, that helps you further. But this is what the type 1 problem, I would say, the easy ones, the basic ones. But as we move further, as I mentioned in the type 2 problems, now we'll focus that some of the derived results could be asked. For example, let's say we discussed during the theory. So let's say a projectile is projected, and they can ask you after what will the velocity. So let's say a projectile is projected with a velocity, let's say u equal to 10 meter per second with an angle, let's say 60 degree, and they can tell you that what will be the velocity after 1 second or half second, or let's say 1/4 second. So that is very clear that we'll use the expression v equal to vx square plus by square root under, and as we discussed during the theory, that the vx, the horizontal velocity, remains constant for the projectile motion. For the vertical velocity, vy is u sin theta minus gt. So vertical velocity actually decreases. So put the value of v. We have already the available values. Theta is there and u is there. So if you have theta and u, and you have the value of the t will be given in the problem. So after 1 second or 2 seconds. See, there is a special case for this. Then let's say they ask, let's say if the time of flight is like 6 seconds, and you are asked that what will be the velocity after 3 seconds. So that is quite clear that you don't need to go into the detailed calculation. It's very simply put, at this is the point at which the body is at maximum height, because this is half of the time of flight. So total time which body takes to travel from point A to point B, from a starting point to the final point, half of this is used for traveling to point A to maximum height. So if the time of flight is 6 seconds, so then then maximum height, for reaching maximum height, it will take 3 seconds. So if you are asked the velocity at the 3 seconds, it is quite clear that at this time, velocity actually is u cos theta. You are given the value of u, you are given the value of theta, you can easily calculate that. So that is one. Another type of problem which can be asked in this particular is, so let's say, we were mentioning it earlier also, that after, if a body is projected with a velocity, let's say u and theta initially, so if after what time the velocity of the body will become perpendicular to the initial velocity. If we do so, if you realize, so in the vector form we'll write the initial velocity. So let's say I would write the velocity at initial v0 is u cos theta I, and u cos theta I plus u sin theta j. Now if you say at a point, let's say at p1, the velocity becomes v1, so that will become u cos theta I plus u sin theta minus gtj. Okay, so this is a very standard problem, and now we have represented in the form of vector. As we are aware, the dot product of a vector is 0 if the angle between two vectors is 90 degree. So what we are saying is v0 dot v1 has to be 0. Now if you deploy so, then obviously we know I dot I is 1. So what it yields is u square cos square theta plus u sin theta into u sin theta minus gt becomes 0. Okay, so if you solve this, what you essentially find out that u square cos square theta plus u sin theta into u sin theta minus gt is 0, and so this becomes u square minus u sin theta into gt is equal to 0. Now taking u common, u by g sin theta. So this is the time after which the body becomes perpendicular to what it was initially positioned. The velocity of the body becomes perpendicular to its initial velocity. You can also get this expression using the another expression that we have used, and which will be like non-vector format. If you see the first part of discussion that we have used tan alpha equal to Vy by Vx. So Vy was essentially u sin theta minus gt, and Vx was u cos theta. Now what essentially we are saying is that alpha in our case becomes 90 plus theta. If you put this, then 90 plus theta will be minus cot theta, and then if you solve it, you would get the same value. So that is but the vector makes it more simplified, or you can use even this expression, but these are how the questions could be positioned. Now another question which can come up is that, as we have mentioned earlier also, that a body is projected with an angle theta, and let's say if the body is projected with an angle theta, and it's like you are given that at a distance a, horizontal distance a, the height of a wall is b, it has to clear. So how you can derive the value, get the value of theta or u. So as I mentioned, this is a question where this particular height is neither the maximum height. So these are not the standard points. Wherever the standard points are not identified or is asked, not asked, where we'll use the equation of trajectory y equal to x tan theta minus gx square upon 2u square cos square theta. So if you do so, just put the value of y as b and x as a, and then if you put the value of theta, you would essentially get the value of u, which is like available for this. As I mentioned earlier also, that there is a cos square theta in the denominator, so that makes it sec square theta, And if you see the sec square theta, that becomes 1 plus tan square theta. So there will be quadratic in tan theta. So they can also ask you, giving the all other parameters, that what is the value of tan theta which will be required, for this particular for this particular body to cross the wall. So this could be another problem which can be asked in the projectile motion. Now another thing that projectile motion we discussed earlier also, that y equal to 2x minus 4x square is the equation of the trajectory, and equation of the trajectory is given y equal to 2x minus 4x square. So if you see what is the value of the horizontal range, or what is the value of the theta. So in this case, if you compare, you directly get tan theta equal to 2 with the equation of trajectory. Plus, if you want to get the value of the range, just put y equal to 0. Or if they ask you what is the value of point with the maximum height, put dy by dx as 0. Okay. Put dy by dx equal to 0 and put dy by dx equal to 0. So if you put dy by dx equal to 0, you will get the value of x. So let's say in this case, if I do so, dy by dx equal to 0 and 2 minus 8x equal to 0. So x coming is 1 by 4. Now when you get the value of x as 1 by 4, you can put in this value and you can get the value of y. So these are the kind of problems. The other problems which could come up can involve, and sometimes the complicated problems also involve air drag and other stuff, which is like important. So I think these are the dimensions of the problem which can be asked. But if you focus on the aspects which we have done, I think quite comfortably you can solve all the problems. Before we end up, we would go into a very quick 2-3 minutes discussion of what all we discussed. So initially, as we discussed the projectile motion, the theory, the basic assumptions which are there, and then the basic results as I mentioned, the horizontal range, the time of flight, the maximum height, and the equation of trajectory, the 4 important parameters. Then with that, we derived some of the more complex results with the help of those results, which you can obviously practice. Those are important to practice, so you need to derive them, and for your practice, for your better concept. And then we moved into the realm of vector. Vector is the mathematics that we used. It makes the things quite simpler. We also use calculus, and then finally we did few numericals. And this is what essentially is lecture. I think that I hope that you have liked the lecture, and as we have mentioned everything from the point of from scratch to everything conceptually. So this is essentially the whole epitomize. I will epitomize it as theory plus numericals. Everything is there in the lecture. So you can definitely go through these lectures carefully, and you will benefit it. Next time we'll be taking up any other class, and send your feedback to us, and we are happy to take up thank you for your consideration, and I once again welcome you from Study Khazana. Join our other videos also, and you can look at very, very important videos. So and for all the other queries, we are always available. Thank you so much.